Awesome, thanks. All right, so we are doing today systems with application. What that means is it's what we did last week, but in word problems, okay? So I know a lot of you don't like word problems because you don't know how to start them. So what we're going to do today is we're going to talk about how to think through a word problem and follow those steps using two different types of word problems today, okay? So when you solve a word problem, you have to set up a let statement. A let statement means you're going to have an X and you're going to have a Y, and you're going to use them to represent two things, okay? We're going to set up the equation, and then using either substitution or elimination, you're going to solve. I tend to use elimination more because it makes a little bit more sense. It's easier for me when we're doing a word problem. Some tend to be easier with substitution or elimination. It doesn't make a difference. So we're going to get started. This first example is very drawn out. Do you see how it's highlighted, or not highlighted, but italicized right there? This is what you should be thinking. The stuff we write down is actually the math that goes with it, but the stuff that's in italics is how to think through the question. So it says a store sold 28 pairs of sneakers for a total profit of $2,220. Style A sold for $70 per pair, style B sold for $90 per pair. How many of each style were sold? So at this point, you need to start the question, and the best way to start it is to look at the very last sentence. If you look at the very last sentence, it usually references what you're trying to find. So in our very last sentence, what is it asking us to find? What are we looking for? How many styles were sold? So the two styles that are selling are what? Exactly. So we're talking about style A and style B sneakers. This is what the question is referring to. Last week we dealt with what's called naked math. It's not in the context of anything. This now is a scenario, and when you have a scenario, you have to use the units. So at the very end, when we get to our answer, we're going to talk about style A and we're going to talk about style B. We're not going to leave it just a number or an ordered pair like we did last week. So we want to set up a let statement. And I just chose X and Y. You can choose whichever you want. So I'm going to say X is style A and Y is style B. That's the first thing you want to do when you're writing something down on your paper. You want to set up a let statement, because without a let statement, when you get to the end, your numbers may be right, but they have to be in the context of the question. Okay? So, now we need to pull the important information from this word problem. Anybody look at the word problem and find something that could be important to us? Dejane. Right. How much is style A? Style A is $70. What else do we know from this word problem? Yep. Style B is $90. The big thing we always want to check for is the total, because the total is going to help us set up where our equations are coming from. Is there a total anywhere in this word problem? A total profit of $2,220. So total profit, $2,220. And if you don't want to write this down every time, if you have a highlighter, you can highlight in the word problem or put a box around it or underline it or whatever you want, okay? There is one other total we need to find. Does anybody know what it is? How many pairs were sold? There were 28 total pairs sold. One thing a lot of people do is they just pull all the numbers from the word problem, and sometimes that works. But sometimes word problems have extra numbers you don't need. So just be careful about just using every single number that's in a word problem. Okay? So, what do we want our final answer to be? Are we talking about money? Are we talking about a number? What are we talking about here? We want the total number. We already know that they're $70 and $90. We want to know how many total were sold. Okay? So, now we're going to put it all together and we're going to form our two equations. And this is the hardest part of the whole thing. So, what I have found is if you work backwards, it's a little bit easier to create your equations. Working backwards means start at the total. So we have two totals. What are they? 28. Exactly. So our first equation is going to equal 28, and our second one is going to equal 2,220. If you have your totals and you work backwards, it's a little bit easier to create. Now, 2,220 is talking about money. Does everybody agree? Okay, so then the pieces of that equation have to also be about money. 28 is referring to the number of sneakers.
Please.
Yes.
I need Tatiana Vargas to the attendance office for checkout, please.
Thank you.
Thank you.
Since 28 is referring to a number, we need the rest of our equation to refer to a number. So, we're going to start with our first equation. Do we know how many style A were sold? No. We know something about them. We know what the cost is, but we don't know exactly. So we're going to say style A is represented by the letter X. Okay? If 28 total were sold, it's going to be a combination of style A and style B. Well, if style A is X, what is style B? Y. So X plus Y equals 28. And those all reference the number of sneakers. But we know details about those sneakers. Since 2,220 is the money, what money information do we know about style A? $70. Very good. So $70 for style A. And like we said, we let X equal style A. So we're putting it in its place. We're using that variable to plug in for it. And then style B is how much? 90. And now that we're here, we basically have what you did last week. We have a system of equations. We have two equations. We're going to get rid of one of the variables, and we're going to solve. Before we move on, does anybody have a question where any of that stuff came from? We're going to do another one like this in just a minute, and you'll kind of see the pattern that develops, and it'll be a little easier for you to set up your problem. So, when we look at it, do you want to get rid of X or do you want to get rid of Y? Y? Okay, sure. So we're going to recopy the question. Whoops. You have X plus Y equals 28, and you have 70X plus 90Y equals 2,220. If we want to eliminate Y, what are we going to multiply my top equation by? Negative 90, right, because we need it to cancel with the Y in my second term. So I'm going to recopy it. You're going to distribute negative 90 into all three terms, just like we did last week when it was just a regular math question. You get negative 90x, negative 90y equals, and this is why we have a calculator, a lot of these numbers are going to get big, and that's okay, because you can use a calculator for it. Negative 2,520. Okay? The bottom equation didn't change. 70x plus 90y equals 2,220. And when you set them up, they should be set to eliminate. Are my y's the same number in the opposite sign? Yes. They're gone. And you're adding to combine them. Negative 90 and a positive 70 is negative 20x. And negative 2,520 and a positive 2,220 is negative 300. What am I going to do to isolate x, to get x all by itself? We're going to divide 300 by negative 20 because you want to do the opposite operation to move it to the other side. So divide by 20 to both sides. And a negative divided by negative is a positive. You get x is equal to 15. Right? Now you have two choices. Which equation is going to be easier to plug into? I would say the first one. Okay? 15 plus y equals 28. How do I get rid of an adding 15? subtract it to both sides.
Didn't you just like subtract 28?
Yeah. You don't have to show this step if you don't want to. We're just writing it down for our notes, so if you get stuck later, you can come back to it. Now, yesterday, just kidding, yesterday was Sunday. Last week, we would have been basically done. We would have put them in order pairs and been set. But because this is a word problem, we have to do the units. And up at the top of the page, we talked about what the units were. We were talking about style A sneakers and style B sneakers. So your answer needs to be with the correct units. So X refers to what style of sneakers? Style A. So you're going to say 15 pairs, style A. And then Y is your style B. 13 pairs, style B. You have to put it in the context of the question and make sure that you match your X and Y up correctly to what the question's asking for. Now that took a really long time, and not every question is going to take that long, but you've got to learn how to think through the question, okay? So let's do another one. Turn the paper over. Anybody need me to go back so you can finish the last one? Are you okay? All right, so in early spring, you buy 6 hanging baskets for your back porch. The small baskets sell for $5. The large baskets sell for $8. If you spend a total of $36, how many of each are you buying? So we know we need to set up a let statement, so I have X equals and Y equals. What 2 things are we talking about in this word problem? Baskets. What size? Small and large. It does not matter. Because you have a let statement, when you get to the very end, you just make sure that you match up your number with what you've set it equal to. Okay? All right, everybody good so far? Let's create the equation. And the best way is to work backwards. So, what is one of the totals in this word problem? 36. 36 is the dollar amount. So we know that one of our equations is going to be a dollar amount. What's the other type of equation going to be? Well, that was the cost. We want to talk about the number, and the number is going to be that there are 6 total baskets. Okay? So we have one equation that's money, we have one equation that's the number. So we're going to set it equal to 6, and we're going to set it equal to 36. And you'll find the more you do these, you only have details about the money. Since you only have details about one of the equations, the other one is just basic X plus Y equals a number. Because small baskets plus large baskets were a total of 6. We know details about the money, though. What details do we know about the small baskets? They're $5. What details do we know about the large baskets? They're $8. Very good. And that's the hard stuff. You know what to do from here, hopefully. This is what we've been doing for the last week. If I want to get rid of X, because we got rid of Y the first time, if I want to get rid of X, what am I going to multiply by? -5 to my top equation. So into every term. Because it doesn't actually change the value of the equation, it's just kind of rephrasing it a little bit so it has what we need. -5x, -6y. I did this again. It's actually a 5. -5y equals -30. Your bottom equation, 5x plus 8y equals 36. And then we're adding. This is just what we've been doing. Your x's cancel. You get 3y equals 6. So y equals 2. And if y equals 2, you can plug it back in to get x. X plus 2 equals 6. So what does x equal? 4, right? Because you subtract 2 to both sides. And the very last thing is to put them in the context of the question. There were 4 small baskets and they were 2 large baskets. All right? Now, those were scenarios, those were situational. You had to use units. The next type of question we're going to talk about is kind of a balance in between naked math, where it's just numbers, and a scenario where it's a word problem. All right? Sum and difference is what we're talking about next. The sum references what operation? Addition. Sum means addition, and difference means subtraction. So we're going to set this up. It says the sum of 2 numbers. Okay, the sum means addition. The sum of 2 numbers is 140. Their difference is 26, and difference means subtraction. X minus y equals 26. I would use elimination. Why? They're already set up to cancel. You don't have to do any work to it. There is no number in front of the x. What number is implied there? A 1. If it helps, go ahead and write the 1 in, because 1x plus 1x is 2x. And 140 plus 26 is 166. And how do you move a multiplying 2? You divide by 2 to both sides. And you get x is equal to 83. Pick one of the equations, it doesn't matter which one, and plug it back into it. To solve for y, subtract 83 to both sides. You get y equals 57. And that's it. There's no units. You don't write them as an ordered pair. That's just it.